So here is a cool mathematical trick, and it's called as the Euclid's theorem. Prove that there are infinitely many prime numbers. So this is the definition of the prime number: a whole number greater than 1 that cannot be exactly divided by any whole number other than itself and 1. And I assume you all know what a prime number is. So here's the proof. Suppose n is the amount of prime numbers there are. And then we can list all prime numbers like this, right? 1, 2, till n. So n is not infinity, we suppose it. And then we assume that it is an integer. And therefore, we can list all the prime numbers like this. And let q equals to 1 plus all the prime numbers multiplied. So this is p1, p2, every prime number up to n. We multiply them and add 1 to them. And q cannot be a prime since it is larger than any prime in our list. So we assume this because we say that biggest there is n amount of prime numbers, right? So if we say there is n amount of prime numbers, then the biggest prime number will be p of n, right? And if q is larger than this number, then q cannot be a prime. However, when you divide q with any of our prime in our list, so let's take p1. When you divide q with p1, you get a remainder of 1, indicating that q is a prime. So what should we take away? If you multiply every prime starting from 2 to any prime number and add 1 to the multiplication, you get a new prime number. So as we did in here, if you take a n, let's say, and multiply every number up until to that index of a prime number, for example, if we select n to be 3, so we should select 3 prime numbers, we select 2, 3, and 5. Then we multiply them, which results in 30. Then we add 1 to it, which is 31. And we all know that 31 is actually a prime number. So this is basically a proof that there are infinitely many prime numbers. And this is the resource that I took it from. You can check it out if you want.